efficiency methods. First thing I wanted to say, this is the way that I do things. It's not to say that ways that other people do things are wrong. This is how I do my things. Again, this isn't something that we need to debate that this is the way we need to do it here or this isn't. So what I'll do a lot of the times, and this is just a quick example of a simple elevation. Here we have 3 different configurations of these frames. There's a cantilever at the bottom and intermediate anchor here. So I know that I'm going to need to model this in RISA. But again, I'm not going to model each elevation. Now, when you're going through PDFs and these elevations are split up over 100 pages, you have a big CAD file with all the elevations split up. What I like to do is just start grouping, pulling elevations in AutoCAD, somehow grouping them together just to get an idea of what elevations line up. So in this case, usually what I'll do is draw some simple lines, line up the elevations, make sure anchors line up, frame heights line up, and then based on this I can determine, all right, I need one RISA model that can cover all these elevations. And this here, this is a pretty clear example. You may not need to necessarily do that for simple elevations like this, but for bigger elevations, this is something that I always find helpful. This will also, as I mentioned, reducing redundancies in your model and analysis so that you're not modeling a couple of the same things twice. Second item, why did you model that entire elevation? So basically we have, this is 2 elevations that come together at a 90-degree corner right here. A lot of the times I'll see when reviewing projects, people will model all of these verticals in here. And basically what that's doing is to help bring down weak axis in-plane deflection of the corner. You don't necessarily have to model the entire elevation. One thing you can do, let's say we just model this small section. These end verticals, you can actually sum up the stiffness, your weak axis stiffness of the members. So if you have 1, 2, 3, 4, 5, 6 members right here, this end mullion, you can increase the stiffness in the weak axis by 6 to account for the additional in-plane stiffness that you're getting from these other verticals. That way you don't have to go and model the entire elevation.
Matt, will that work if you don't have any horizontals?
No,
okay.
It will not. Good call. Yeah, if you don't have horizontal, now that's a case, if you don't have horizontals, I wouldn't even model this much. All I would do is just model these last 2 bays, because really all you're doing is looking for the analysis on the corner mullion.
Why won't it work if you don't have horizontals?
Why won't it work if you don't have horizontals? Any of the new guys? So here we have a 90-degree corner mullion. Your elevations would frame into that. Now, if you have wind pressure blowing on this, on one face, what's going to happen to the corner? It's going to start deflecting basically in 2 directions like that. So you're getting some deflection, in-plane deflection along there. Now, what Stuart was saying, if you have another vertical over here, and you don't have a horizontal connecting these, is this vertical going to move? So here's your corner in question. Now you don't have any horizontals tying these 2 together. This adjacent vertical, see any in-plane movement. So that's why in this case, if you got rid of all these horizontals and and this, your corners deflecting over our allowable in plane, you're not gonna be able to model this in any way that these adjacent verticals are gonna help out with that deflection, since there's no horizontal to transfer that. That's kind of how I would take care of a situation like that. Again, it helps you cut down on time modeling this whole frame.
Are you assuming that all of your verticals are the same part?
Yes. Now,
So what do you do
so-
if you have a bunch of SSG verticals, but your jams are captured? And you need to look at the jam deflection and the DLO glazing pocket deflection. What do you do on situations
So
like
in
that?
cases like that, this will get a little more complicated. If the captured mullion it is a stronger member, I would, if possible, just use the SSG and call it conservative, because you know if the SSG works, the capture works. So yeah, we can throw in a million different little things like that, but yeah, that's something good to know. That when I'm adding the weak axis values, actually, well, even if you have, I guess if you have SSG captured, you could still add up the stiffness. That's all you're needing. So you're not actually doing an analysis on those other verticals. So
The
you
main thing
could do
is
it that
you
way.
need to make sure that when you're looking at the DLO deflection and the biaxial sheet that you're using the correct captured
Yeah.
or sealant SSG deflection methods.
Yep. Okay, so that's a corner condition. Another item under why you should model the entire elevation, because typical mullions fall in corner zones, but the jam doesn't. So just because you have a situation like that, doesn't necessarily mean that you have to model a corner wind pressure and a typical wind pressure. Here's kind of just a general example. Big old elevation, on this side we're dead loading at the sill, got an intermediate wing load, intermediate, and we're cantilevered. Over here we have a step up where we're dead loading right here, intermediate and cantilevered. What part of this elevation would you guys model? How much of the elevation would you model? There are no corners on here, and the whole elevation's in a typical zone.
I'd model a stick. A single stick.
2-6, one for left, one for right.
Well, you need 3 for that step, right? Is there a little step that goes up?
Right here?
Yeah.
Okay,
Oh.
I'd probably model the 3 to the left of that step and the 3 to the right of that step, just so you have a good view of that middle one, and then you've got a typical on each side and a jam on each side.
so you're gonna do something like that.
Yeah.
Okay, explain why we would just model this.
So for me, the unique things you're checking are that far right one is kind of going to act like a jam, so you can check your sealants and stuff. The one right to the next to that is checking a different span condition, but it's a typical vertical for that span condition. And then the next one over, you've got that step in there, so you've got a weird wind load condition, and you got to check where that detail's calling out, make sure the sealant will work down there. So you kind of got that in there. And then the next one over is another typical vertical with a different span condition. And then the next one over that is a jam with that span condition, so you can have the deflection for the sealants. So you kind of cover that whole, everything you need to check.
Yep.
And even if that jam on the bigger model, can you go back to the bigger model? So if for some reason your jam on that bigger model, like the DLO on that jam is much bigger than your
Mhm.
typical DLO, I would model like Matt was saying and just make that one opening the same size as that jam. That way you're covered on that.
Yeah, so that's something that I've done before. So you're talking about like on this,
Make it-
actually making it a wider DLO than it
To
actually
cover
is.
the jam.
Yep.
Yeah.
Now, I would say, yeah, that's great as long as it doesn't negatively impact.
Overload that.
Oh, yeah, and that we need steel because that's not an actual
Yeah.
case. But yeah, if we increase that DLO, that'll cover our jam know that this works with the larger DLO, thus that vertical's fine.
On the overloading, quick thing, ratios are really good for that. You can
That-
ratio down the deflection and the moment because they're linear, so whatever the trib width is.
So yeah, that's the other thing, we can just keep the model like this, we don't even need to increase that.
Yeah.
But then, with whatever deflection and moment you come up with for this jam, you can increase that by the ratio of the true trib width over what we've modeled. So that's another way that, okay, we don't need to model several different things, we can.
Can I ask you too, Matt? On this one, let's say what you're talking about, the jam is like 35 inches. It's like a few inches. Do you stress about a few inches, or would you just model the typical one? Cause that,
Well, I guess what do you?
so
but it's-
like, that's 33. Is there any kind of a tolerance where if the jam's like a few inches bigger that you don't worry about it so
What
much?
I would look at, I'd run this model and look at the values we're coming up with. If we're right on, a couple inches isn't gonna do a whole lot, but I may make the justification, but again, you have to have some rationale for it.
I just read this.
If you're
Curious
at
thing.
like 60 or 70% capacity on deflection and stress, just say by observation, you know that it's gonna be a couple inches, isn't gonna kick us over. So again, this is a simple way to take something that looks very complicated and take it down into something that's really manageable. Alright, next item, clearly label numbers in ways that make sense and are easy to follow. And this is on sheet 3 and 4 of the PDF. So if you look at these, the labels, the member labels.
That you just got split up in there.
Oh yeah, I know. So if you look at all these are basically just the standard default member callouts that RISA puts on. Now, if you look at the verticals and you're doing an analysis, does anybody see any order to this at all? That if I'd say, okay, we need to look at M25, and you're reviewing this and you find an M25 sheet in the calcs, all right, how are you gonna find this easily on a model like this? And something like this is a smaller model, but if we have bigger models, it can be very tedious to find, not only when you're reviewing, but if you need to go back months or a year down the line for your own calcs and try to figure this out, it's gonna be tough. So this is how I do things. I always label my verticals left to right. So in a case here, JVM, jam vertical mullion, 1 is what I have for this whole thing right here. And then I split it up into the sections 1, 2, 3, and 4. And verticals go the same way. VM1, vertical mullion 1, vertical mullion 2, 3, and jam 2. That way, if you say, okay, where's vertical mullion 3-3, I know that it's the third mullion over 3 up. So I know that other people have different ways of labeling things, but try to find some way that works for you, that's easy to reference, and that's not just a whole bunch of random.
Is it difficult to relabel that in RISA?
Now, that may be a question for Ryan, because I'm quick at it, so I
Right.
do it, just type in everything. There
I
may
was
be a
gonna jump
quicker
in on
way.
this. So if you go up to tools, there is those options to relabel joints and members, but if you use those, RISA basically just goes through and does 1 through whatever.
In
And
the
there's
order
no
that you
real-
put it in,
Yeah, it's gonna look like what you printed out if you go and redo that. It's just gonna renumber things.
Right.
So what I'll do with some of these, I won't go through and relabel them like Matt will, but on the printed set, like what he's got that's in the handout, I will highlight over the name of the member I'm checking. So it's in yellow or green or some bright color, so it's really easy to pick out where on the model it's actually at. So you're not necessarily going through and relabeling it based on where it's at on the frame like Matt does, but it's still very easy to find when somebody's reviewing and looking for it.
Yeah, and again, something like that, I've seen other people do stuff like that, as long as it's clear and easy to follow.
Do you just relabel by clicking on it, double clicking on it?
I'll
and
go in, type it, go in.
If
Right,
you go to the
and so you
spreadsheet,
do
if you go to the spreadsheet though, can't you create a list on like Excel that you can easily just drag down and the numbers increase and then paste them there?
I guess you
type
could,
them in
but if
there.
you're doing, yeah, I guess it depends on how you actually, like for the horizontals, yeah, couldn't you do that?
You could, but there may not be any kind of order to where it is on the model. That does not just go like bottom up.
Yeah.
It depends
So
on
you
how
ha-
you drew it.
You have to be careful that you're not.
Oh yeah, because
mislabeling,
if
a
it's
member,
all an M, like if you sort it, it's
So if,
Yeah,
if
it's
you
still
do like
gonna-
what Javier's saying, that H1 may be top right of the model and H2
Yeah.
may be in the
so
middle or
it's
something.
the exact same.
It might be worth it for like a model that you only have verticals, that you know that it goes in a certain order to do V1, V2, V3, and just drag it down in Excel, copy and paste it.
Yeah, yeah.
Now, one good thing about this, while I have it open, that helps me go faster, is you know how for horizontals you have to do one that's fully released and one that's just released for bending. If you go to the advanced tab, when you draw the member, you can put them all as just both pinned, and then go back, highlight the whole entire section, and just fill with all pin or whatever you want to do. And it really, to me, that helps go really fast on those.
So what you're talking about, this also gets into why I label these. So I'll go through, do all that. Once I have all my horizontals labeled, I'll go in on this one, set my end releases, go into your advanced, sort, and then, so the first horizontal will have these filled in,
Mhm.
and then I'll just copy everything down.
Okay,
up
I'm
to,
at-
up
But
to
see,
I
what
get
I'm
to-
saying is like go to draw a member, like go to like where you're drawing a brand new member.
Oh yeah, yeah. Oh, I know what you're talking.
Yeah,
you can select
you're
that.
setting
so what
them.
you're drawing.
You're setting them both as pinned.
Yeah, I know that that's
then
that I can do
that's
that.
what I do.
just never do it.
Oh,
Have you ever used the selection tool that's in there?
Wait, the selection
So
tool.
click on the little question mark, third from the bottom over on the left.
You can highlight different
Wait,
members
where?
and make
The
them
left
active.
sidebar, it's the third from the bottom, it's that question mark.
This.
So this allows you to select members based on name, member type, all that stuff. Go to that member tab. So up from, where's it at? There's a way to select based on name. So I think that from box, if you type in just HM and hit apply, it should select all your horizontals.
Let's try that. Oh, that's nice.
So then you can apply your releases using that too.
Why haven't you told us about this?
No, I told someone.
This is stuff that I never even. Yeah.
He can show you. Trust me, he can show you how to do that 8,000 times. You go do it yourself, and it doesn't work.
That's
one
why I'm just like
Trust
I'm
me.
sticking with what I.
one good thing about labeling too is that when you click on the results tab, like on the analysis tab where it shows you the moment and deflection, the label that you use is clearly displayed on the header of that printout.
Oh, yeah.
If you run your analysis and then click on the, so you could highlight it on your big model there, or when you click that,
Sorry.
you have it
Yeah,
right there. very
That's
clearly.
that's another plus of labeling. You can see exactly what you're dealing with.
So I have a question on how you do it. One of the things that I struggle with most in RISA is printouts, because I never get the scale right to where it's legible for. It's either way too small or it's way too big. And
Right.
how do you play around? Do you just you're just playing around with it till you get one that looks decent?
Yeah, usually I use like 1.5 or yeah, it's set at 1.5 and everything's legible.
Okay.
That's something. Yeah, whenever.
Depends on the size of the
Yeah,
Yeah, it's,
On
you-
these bigger ones like this, sometimes you might have to bump it to 2.5. I've had to use 3 sometimes on really big frames. So
yeah,
it's-
it all just,
you really just need to
it kind of
print one,
depends.
see what it looks like until you get to a point that it works, and then just run with it.
Yep.
Okay, so I'm doing it right, just,
Yeah, there's,
I'm
there's
not good at
really-
selecting what looks good.
There's
It's
not
like
a better way to do that.
third try, okay. It'd be helpful if we could just say we're printing to 11 by 17 or 8.5 by 11,
Mhm.
scale to fit page and look decent.
That'd be
Come
cool.
on, RISA.
Okay, any other questions, for that?
Well, you guys, I mean, it's
Are you gonna
2019.
touch
we're-
on later on what to print on the calculations? Like what printouts really need to go there? Because I think that's an area where,
You talking about like, do we need to print out for all the members for JAM or?
that, but also when you're putting together your calc package, what do you need to show from your RISA model? You know, like end releases or local access or moments, like,
I'm not touching on that simply because that's more of a calc format. It's not so much an efficiency thing. That's something that we can talk about maybe in the future, like exactly what things need to be printed out. Okay, next item, modeling typical horizontal mullions, head, intermediate, and civil. I'm not sure if people do this, but if you look at sheet 5 of the printout, here's the same elevation basically with all the proper extrusions, particularly for the horizontals, in place. So for your horizontals, you actually have 4 different horizontals on here. Now, that's going to take additional time to make sure, especially for the head and sill members where we don't typically get section properties, gonna need to go through, find those, make sure that every member is the proper section. Which again, it may not take a whole lot of time, but it's taking some additional time on this. What we really can do, so here you can see, I basically have all the horizontals the same. The reason for this is because the actual section properties of these horizontals, especially since they're released at the ends, isn't having a big impact on the vertical member analysis. So, and there is an exception if we're modeling something where the horizontals, we're actually looking at them and doing an analysis, then we need to model those correctly and put the correct section properties in. But for a case like this, where this model is primarily for analysis of vertical members, I wouldn't waste my time going and putting in all the correct horizontal section properties. Any questions on that?
and to add on what you're saying, really the only other time that you would need a RISA model for a horizontal member is when you're taking a look at door headers for the deflection of door headers and how they're loaded. In that case, sometimes our clients like to have 3 or 4, maybe 5 stacks of DLOs stacked on top of an opening, and that's when we need to really make sure that door header is not over deflecting or the door won't open. That's a big problem.
Yep.
Or that one, sorry, just to tag on, the one you have in the model is kind of a unique deal.
This
You
right
say
here?
that? Yeah.
Yeah, so this is another case, if you're gonna use this model to actually look at this horizontal, since we have another vertical tying into it, again, you can leave all the other horizontals as is, but make sure that this member right here, is actually the correct member that we're analyzing. Page, dead load on horizontals. How many glass sizes? So, if we go to sheet 6, I've seen a lot of people doing it this way. There's nothing wrong with it. It just is more time consuming. So if you look at sheet 6, you can see this is basically all the point loads are representative of the glass weight on the two setting blocks that they sit in. Now, this along with in RISA specifying a negative gravity load, which would take care of the weight of the frame. This is this is a correct way to do it. The thing is, for a simple model like this where we're looking at verticals, there's no need to do it this way. What you can do is basically just have your linear loads based on tributary width of your verticals and apply those to your verticals. That's going to give you the axial loading that you need. Again, you don't have to, especially where we have elevations with numerous glass sizes. And I know that we have spreadsheets that we can input things, but that can take a lot of time. So modeling your dead load like this, very simple to do. Now, in a case where, let's say you have this door header and you have a vertical right above it, that may be an instance where you don't want to use the linear load, because then you're having a very high concentrated point load right at your horizontal, which even if you're putting your point loads on the horizontals, you're still going to get that load transfer into your vertical, and there will be a point load down here. But when we use point loads in a case like that, it's going to be a more accurate model and can help us out with deflection at the on your model.
Just be careful to add the steel weight when you do that.
Yeah, so if in a case like this, that's another thing. I'll have my dead load, which is just the weight of the frame and the glass. If I have steel reinforcing anywhere in here, I'll have another line for dead load of steel, and then put the linear load right where the steel is for the weight of the steel itself.
Can I add one more?
Yep.
Like, is an even easier way to put those linear loads on that I've started doing? If you put it on with the same way you do your wind in the Y direction, and then you force it to do A-B distribution, it ends up all as the exact same linear load.
Does it? Have you compared the two?
Yeah, they're the exact same.
Okay.
So then you
that's
just don't have to add
that's
anything.
another way.
So yeah, do -6.5, and then change that distribution to AB. And then if you put it on, yeah, from the bottom left and go around. Oh, you had to go to the, sorry, I usually go bottom left, then bottom right.
That way?
Yeah, that way.
See, I do it complete-
And
I do it the other way.
You just
That's
have
how
to-
I've always.
You just have to change your
Yeah, so there we
distribution.
go.
So then now that just puts that load on your verticals.
So it's an in plane.
Oh, so
So
you
it's
input
okay.
as a PSS as an area load, but just on the vertical?
Yeah, so when you do that AB distribution, it only applies it to your vertical members.
Now, the one thing, I think another reason why I don't typically do that, if you have a case where you have any type of sloped glazing, it's not gonna be correct, because if you have your glazing this way with a load that way, it's gonna force everything.
Won't be,
Or-
won't be a true dead load, it'll be in a plane.
Yeah, and even if you do an area load facing
That's
in the
correct.
Y direction,
Mhm.
it's going to load the glass in plane. Or maybe I'm talking.
The one that's
It's
moving,
not gonna load it.
Basically,
Accurately.
this can only be used for rectangular frames that are completely vertical.
Right.
And you have to be very careful about the layout, because RISA can do very weird things with this if there's
Yeah.
different geometries in the frame, because it's making a lot of assumptions on how it distributes that to those verticals.
Well, the other thing, it's not only distributing to the verticals, it's distributing to all the horizontals as well.
Using
This won't?
this AB setup does not. It's a one-way load, so
Okay.
it's only going left and right. But that's another thing you've got to be careful about. How Matt told you go counterclockwise when you were drawing it. If you go the other way, using AB is not the correct setting. You've got to pick one of the other like BCs or
Yeah.
to make sure it matches the way.
So, okay, so in essence, if you're using this, you need to be very careful on.
Yeah. Double check your loads. Make sure it's actually distributing. it
But you
the
need
way-
to idiot check yourself and just run a DLO load case and see how it's distributing it through your, whatever those, I'm trying to say.
Once you
And
run
you
it,
drop down your transient loads or whatever.
yeah, just check your
And then it'll show if it's just vertical or just horizontal.
Will it load the horizontals if they're not selected or inactive?
Yes. If they're drawn in, they're actual members. If you set that to like a two-way load accidentally, it will load the horizontals. So then the other thing about this, go up to settings and go to global.
Go to what?
Solution tab. So that area load mesh, that defaults to 1 square foot. So if you're doing this area load and you've got weird DLO sizes that don't break down to just 1 foot increments, RISA's gonna make some assumptions about how to split that load up, and it's not gonna match your hand calcs.
So I would
So-
say for the new guys, don't do it this way.
Yeah.
At least for right now.
Until you've got a good grasp of what RISA's actually doing with those area loads, yeah.
Because that's actually another thing, and now that you're bringing this up, I've always assumed that it's being applied correctly, and now that I know that there's the AB and the direction, well, that's
You
just
see the
something.
line there? If it's a horizontal line, that just tells you it's going to your verticals. That's how the AB, so like, change sorry, I don't wanna get into it big, but change the dead load to like BC if you want, in your, whatchamacallit.
Can I do that just right from
Mhm.
here?
Yeah, go to that area load, so change your distribution to like BC,
Then run it real fast.
and now the line's vertical, so now it's only applying to your horizontals.
Wait,
Hmm.
what?
Run
Listen to
your
the-
analysis real fast.
The big, arrow,
Well, I guess we should.
Oh, okay, gotcha.
Yeah.
Yep.
that just tells you it's going out to your verticals.
If you would run it without the one load.
Yeah, okay.
And then did it and looked at how the distribution of the load is going, you would see horizontal distribution now versus pure vertical.
Okay.
But yeah, I don't know, I hate putting little hand calcs in my PDFs if I don't have to, so that makes it so that you can just.
Here's one other thing that I've actually started doing because and this is again something that it's conservative, but if it works, I have no issues with it. This max linear load for the intermediates, I'll also throw those on jams, because I know that if that axial load, if the jams work, or if the intermediates work, the jams are the same number, it's just conservative, it's easy to do, it's not impacting anything, it's not impacting anchors, so that's another way that I can just throw a constant linear load on all of them. Okay. Item number 6, this is getting into something similar to what I was just saying about being conservative. If feasible, be conservative unless that leads to additional challenges or steel reinforcing. So what I'll do, good majority of the time for a frame like this, I'll go ahead and run it, and I'm gonna pick and choose what vertical or what verticals that I look at and what values I input into RISA or into our spreadsheets. So if you look at sheet 7, so I guess it's the very last sheet in the print off. The first 3 sheets there, I've highlighted the maximum moment or maximum axial load and then your area with your maximum deflection. Now what I'll do, if you look at the second to last sheet, I'm taking those three values, the highest three values for the entire elevation, and combining them into one analysis. Now, it's true that one specific vertical is not going to see those three occurrences, but if one vertical can withstand the max of all three, everything's good. So you don't need to, I wouldn't need to do a check for this member, VM3-1, which has the maximum axial but a lower moment, and then check 3-4, which has basically no axial and a higher moment. Why go through checking numerous verticals like that when you can combine it all into one? So that's what I did on that second to last sheet, and basically it's a coverall, conservative way of looking at it. Another way to do it, Matt does this a lot, the last sheet is basically just throw in arbitrary maximum moments or maximum axial loads to determine what values the moment in question can take. So on that last sheet, for this particular vertical, again, looking at just an arbitrary 1,500 pound axial load, you can have a maximum 3,500 foot-pounds of moment and still call the moment good. So if you do a check sheet like this, then you can print out the detail sheets on your model. Just make a note, okay, based on this analysis sheet.
So what I've done with that, it's kind of like using a control sheet. Say, okay, you're using Mullion WW500.
Yep.
Or
Yep.
have a control sheet at the beginning of your RISA models, and look at the total allowable moment there, the one that's calculated by the sheet, the 3,821, and use that kind of as a guideline to see if you'll need reinforcement or something. And if you don't need reinforcement anywhere and you're fine with, and your maximum moment is well below that one or below that one, make sure on that sheet you're putting your maximum ombre strength, like Matt's saying here, and then you don't really need to be forcing a value onto that set.
What are you, so if you're using your maximum moment, what are you doing about axial?
For that, yes, I would add an actual load based on whatever you're getting at the moment to see that.
Okay, so it's something similar to that.
On the summary sheets, though, sometimes what I do is I just use that moment, that MN, and you know how we have that cell.
Yeah.
I would make sure, especially for open shapes, that I use a maximum umbrage length and the
Yep.
moment that comes from it, and use it on the summary sheets.
So it
And
flags.
on the summary sheet, it very quickly flags if it's okay with reinforcement or a moment.
Mhm.
But that's something a bit different from like a RISA model.
Yeah.
And then the other thing, like you were mentioning, I made note that I'm actually conservatively using the maximum umbrace length on the entire elevation along with your smallest span, because first off, the smallest span is going to give you your smallest allowable deflection, and then your maximum umbrace length, it's going to give you the weakest the moment that you can take. So it's all a conservative design. Now, I only use this if it's not causing me to add additional steel or make modifications. If you have to make modifications, then don't be so conservative. Start looking at more detailed checks on it.
One of the notes that I would like to make on that, whenever you're using a sheet to kind of set up a max or a framework where you know that it's going to be the maximum, look down at the unity. The unity on this is 1.0. Don't let that unity go up to 1.04 on something that you're going to use as a max. Just use the unity of 1. Okay. for something where we use a framework to, you know, classify our members.
When, just kind of build on what Stuart's saying, when you're doing that using maximums, or like Javier's saying, you're mixing lengths with maximum umbrace that may not be on the drawings, make sure you're noting that that's what you're doing for like me or Matt when we're checking it, so we know that's what's going on and it doesn't look like a mistake. Cause I've run across that before where I'm checking a project and it looks like you're mixing stuff when you didn't intend to do that.
Okay, item 7, compare members where possible. I kind of touched on this before. This is reducing redundancies in your analysis. So if I'm looking at vertical mullion 3, it's the exact same mullion as your jam. Everything checks out stress-wise. In this case, your jam, we have a 3/4 inch sealing joint, so your allowable movement's 0.84. Clearly, since the member's the same, it checks out stress-wise for your typical. You know that the jam's gonna be the same, that it's gonna be fine. Since your intermediate vertical deflection is under the allowable for your jam, again, you know that your jam's fine. So just based on this analysis, you don't need to do anything with the jam. But do make a note in the analysis for this vertical that the jam's okay by comparison, based on 3/4 inch sealing joint. So again, that just eliminates unnecessary review. The other way to do that, and we talked about it, that if for some reason if there's a condition where, let's say, you're modeling this elevation and it's all in the typical zone, you have a jam condition that falls in a corner zone. You don't necessarily need to model that in a corner zone. You can, so in this case, if we have, here's our deflection, 0.32. If we have another jam that's in a corner zone, we don't want to model that. We can bump up this deflection by a ratio of the corner wind zone pressure to typical. So essentially, since you're essentially factoring up your deflection for that corner zone. Same thing with your moment. You can factor that up based on either the ratio of your wind pressures or ratio of your trip widths, if need be. Okay, questions on that? And then final item on here is basically keep your models as simple as possible. Don't add more stuff than you actually need. Don't model more members than you actually need. This was a model, this was several years back. It's fairly complex. What's going on here? So it's basically sloped curtain wall, and these areas out here, these are sunshades that are sticking and projecting off of the curtain wall. Now, a couple things on this. If we're going back to labeling members somehow, with the sunshades added to the model, it gets there's a lot going on in keeping track of members, or even making sure that the releases are correct, loads are correct. There's a lot of room in here where you can have errors. So what I would recommend on something like this, again, the curtain wall itself, it's sloped, it's corners. I would still model the entire curtain wall. What I would do though, if possible, model the sunshades in a separate file, so that you're just isolated to your sunshades. And then once we have those loads, go back, apply those to your curtain wall frame, in whatever load combinations are necessary. Doing that will make things a lot easier especially again, if you have to go back in the future, it'll make things a lot easier for you. So wherever you can minimize the number of members, or complexity of the model, it's gonna help you out.
One thing I find challenging when bringing loads from another model, which I've proven myself that it's 9 out of 10 times it makes more sense doing it like
Right.
what you're saying. Watch out to, I mean, I guess the question is, what's your best way of not being overly conservative and loading full snow with full wind? Because sometimes that is overly conservative.
So
You have to be careful that you're not either like reducing it too much by
you have to
another
make sure
factor.
that, so if I'm just looking at the sunshades, I'll have all the proper load cases specified in here. And then that's kind of a thing where I'll go through and like the first load case, dead load, I'll just start eliminating some of these because I know that it's not gonna control at all. So that's the first area that I'll just start eliminating some load cases that I know aren't going to be used. And then I guess that's kind of a project thing that I just need to kind of look at it and see how not to do that. Basically, a lot of the times I'll take the reactions for a given load case from the sunshade. I'll still have all the load cases for the curtain wall, but then just put in those loads for that given.
The maximums of the sunshade.
Yeah, so if it's a case where you have full snow load,
I mean, I guess you can reduce it on that table because I think there's a combination of 0.75 snow and 0.75.
So like on number 3, if I put on the full snow load from the sunshade onto the curtain wall, I'll also reduce wind pressures on the curtain wall by whatever factors there
on
are.
that sheet, yeah.
So again, we're sticking with the load combinations and just reducing them where.
Do watch out though if on your sunshade model you already took out the reduction for wind on the wind updraft on that sunshade.
Mm-hmm.
If we apply it again here, once we have if we're simply applying the reaction loads from the sunshade, you need to be careful that you're not kind of like doubling that reduction. See what I'm saying?
Oh yeah. So if in this, so like here on the 0.75 snow, you want to make sure that so we get a reaction for that.
Yeah.
When we put it on the model, you're saying don't reduce that by 0.75 again. Yeah.
So you just need to be
Use
very
full
careful.
snow
You-
on the
yeah.
sunshade model,
You're-
and then you.
Yeah, so any of the loads that you're getting from sunshade, you're taking those, you're not modifying those at all when you're looking at the curtain wall. You would just be modifying the loads other than sunshade applied.
Yeah.
Also,
Quick question about this, and I haven't had this happen on a project yet. There is that load combination where you have the 0.75 snow load and 0.75 wind load. When you have a corner situation where we're looking at the full pressure off of each face, and then the 75% on each face, is that 75% of the 75% of the wind load?
no. Wait.
You know what I'm talking about?
Oh, yeah, so we look at 75, the unbalanced.
Yeah. I've never ran into the situation, but is that something that we could potentially apply?
I would think so. Couldn't we do that? Because if you have 75 positive, 75 negative, if you put in that would be your 100% win for that loading.
Yeah. It's for the unbalance.
And-
It's for the imbalance load, so
and-
it would still apply.
It's 100%
So,
of
yeah,
the unbalance.
if
So
you're
to
going-
that you apply the 75.
Yeah, if you're gonna
Okay.
put in 75% snow, 75% wind, you would reduce those again by 75%.
Okay, I'm just curious because I've never ran into that situation. But
Because you also have the 100% wind without the unbalance reduction,
Yeah.
to which you do apply the 75%
Yeah.
reduction on the load case.
So in a model of sunshades, that would be something like that. I would also reduce the complexity of if you have an individual model for the sunshades, there's a lot of ways to reduce the complexity with tributary areas
Yeah.
so that you get maximum loads for your sunshade, and then you can actually back it into your model with actual tributary ratios.
Now, can you zoom in on a sunshade and turn on the load, like the load case view? So yeah, select that one and just turn on the snow load. Yeah. So like Stuart was saying, those loads are linear. So they're going to be if that sunshade gets twice as long, your reaction point of the connection with the curtain load is going to be twice as much, basically. So you can use that ratio of the sunshade dimension to dump your loads into the curtain.
Yeah, so
And play with that ratio as you load your curtain load.
Yeah, so you can really simplify your sunshade models and then use ratios of those loads that you have as an output to input into your curtain wall. And that simplifies a lot of the work that you have to do.
This was a monster of a project.
That was a heck of a project.
Yeah, I absolutely hated it, but yeah.
Is it also tapering?
Yeah,
Yeah.
on
Yeah.
all directions.
So,
It goes out like that. It had sunshades. It's in Seattle. No, it was in Washington State. So our snow loads were just ridiculously high.
and you get pictures of it now.
Yeah.
It's nice.
It looks nice, but it took me weeks to do
Is it on a
it.
casino?
No, it was like an office building.
This was one, and I mean, this is a good example about how on something this complex, you need to be on top of it, because even we were having issues with the different end releases and that
Yeah.
throwing torque into the system. So yeah, anytime we can simplify these models.
And
it's just gonna help
this
us out.
precise project actually taught me, like forced me to see a frame. Okay, if you have a straight frame that doesn't do all these crazy things, a straight frame with a sunshade, don't even think about trying to model the whole thing together with the sunshade. Just model your sunshade, dump the load, and be done with it. This was kind of wasn't an oddball, but it shows you how quickly you can overcome.
The other thing with that, if you're looking at, if you have an outrigger and you're trying to find the deflection of that, it's gonna be off because as your curtain wall bows out, then that's gonna deflect
Yeah.
differently with it, and then you have to figure that out, so.